Mathematica and the Raspberry Pi. RC circuit analysis. This is a simple RC network and its transfer function. Here's the transfer function, its plot definitions, and the plots. The magnitude phase plots are more meaningful when plotted on a logarithmic frequency scale. Engineers prefer to plot the magnitude in dB and the phase in degrees. A much simpler way to do this is to use the Bode plot. I omega is replaced by the Laplacian operator S. It is also possible to plot the real and imaginary components of the transfer function. Mathematica has a real imaginary plot function. The two components can be identified by using the plot labels expressions instruction. The input impedance of this circuit is simply the resistor value plus the capacitor reactance. Adding a resistive load across the capacitor has a drastic effect on the input impedance. We can write a differential equation to describe the voltage and currents in an RC network and then use Mathematica to solve the equation. In the first example, we'll apply a fixed voltage, write Kirchhoff's voltage law around the circuit, solve for the current, and plot the result. Here is the differential equation written in Mathematica language, and here is the result after we run it. We input Mathematica solution, put in the values for our variables, and then plot. Since we know the circuit current, we can now calculate the circuit voltage and plot. We can also write Kirchhoff's voltage law around the loop and solve for the voltage across the capacitor. Here's the problem in the Wolfram language. Here's the solution for the capacitor voltage. This is the circuit voltages. We can now calculate the circuit current and plot it.